Hello guys. We're gonna get started now. Can you guys hear me okay? Yeah. All right. Yes. Welcome to Reverse Engineering 1. Today's meeting, where I'll be discussing reverse engineering. So let's get started. First, some announcements. We've got fall CTF this Saturday at the SIF at 12 p.m. So be sure to come out to that. This is our biggest event of the year. You won't want to miss it. If you haven't signed up already, the link's up there. It'll be a very fun event. Hopefully you guys have all signed up now. All right, look at our scoreboard standings for our internal CTF. So far, it's like Ronan is doing pretty well, and then Noel X. Okay, I don't know how to pronounce these. You guys can look at these. Good job. Y'all were playing so much. Okay. Excellent. So this is our meeting flag for today. Go ahead and type this into meeting flag for today's Rev 1 meeting at ctf.sigpwny.com. I'll give you guys a moment to enjoy this meeting.
Yeah, this thing is fucking annoying. Just a little word.
All right, hopefully that's enough time. Let's get started. Let's look at an example. So here on the screen, I have some Python code. Even if you guys don't know what Python is, I'm sure you can tell which one of these is easier to read. So let's have a show of hands. Who thinks the left side is easier to read? This side. Okay. All right, I'll put your hands down. Who thinks the right side is easier to read? All right, I'll take note of this corner here. I don't know what they're talking about. But clearly the left-hand side is easier to read. Right? It's got some neat words there, like the function tells you maybe that's what it does, Fibonacci. Has some variables that are nicely named. It's structured in a reasonable way. If you've taken some more CS classes here, you recognize these as like your base cases for Fibonacci. And then on the right hand side, this is terrible. It's got terrible names, variable names, and the control flow is all bizarre. There's these random, like, I don't know, while and then else. Like, what is that even? So let's talk about this. How do we turn the code on the right into the code on the left? Because unfortunately, many of the code that you see out there is going to be in a format that's not easy to understand. And that could be because it was compiled into something, or maybe it was purposefully obfuscated or made more difficult to understand. All right. So an overview of what we're going to talk about today. I'm going to go over the basics of reverse engineering, give you guys some techniques, and then we'll end off with a couple of examples. And feel free to interrupt me if you have questions anytime. Just raise your hand. You know, we want to be a close-knit group here. Okay. Basics. What is reverse engineering? The motivation here is reasoning about code, about what a piece of code does. Okay. The reason we want to understand code is because it is the ultimate source of truth. It tells us what a program does. There could be documentation. There could be comments. Now, those might be misleading. They might be wrong, but the code is always correct. This is something that you have to understand, that even when there's specs to how something should be done, that might not always be how it is actually done. So this is one of the reasons we want to understand code. All right. Now, the two main types of analysis for understanding code is going to be static and dynamic analysis. Now, these are not inherently opposites or anything like that. There's plenty of techniques that use both of these. But these are like the main categories when you're thinking about looking at a piece of code, how to try to understand it. So static analysis is reading the code and using tools to automate that reading of the code. You're not actually running it. You have a much more limited information about the state your program is in. The advantage of that is that you can often understand it more. Oftentimes it's easier to get running because you have to run the code, you can just look at the code and however format it's presented, such as a text file or just disassembling the binary. On the other hand, dynamic analysis, you're running the code. You're seeing what happens as the code runs, and you're able to trace through the different states that the code encounters. So this is good if you have a big complicated code base and you don't want to manually look through all of that. And it can be more accurate than static analysis because you're running the entire program in the given environment. All right. So let's talk about some abstraction levels. We have this little diagram on the right here, a different abstraction level. So not all code is written equally. Some code is easier to understand, higher level, and some code is harder to understand or lower level. So what we want to do is be able to look at low level code and then somehow transform it into higher level code. Now this transformation is really hard because if it was easy, then a computer could be doing what we're doing, reverse engineering. The opposite way, though, I like to point out, going from high level to low level is pretty easy. And that process is sort of compilation. Not really, but it's sort of. And that part can be automated. Okay. So let's go through a quick example of dynamic analysis. Up here, I've got a program. This program asks the user for a certain number, and then I'm putting in a number, and it prints something. So in the first case here, I entered 4, and then I entered 10, 0, -4, and then it gives out different outputs for each of the inputs that I give it. So what do you guys think it's going to output when I put in 7? I'll give you guys a minute to think about it. I heard a number. What was it? 11. Okay. Anyone else? Any different numbers? Doesn't even need to be a number, right? I don't know. We don't know anything about this program. All I've given you is this output. I've told you that I'm interacting with this by putting in different numbers. So, any other options? No? All right. Another question. What do you think the code is going to look like? Any hypothesis about if we were to write this as or any guesses to what the program is behind this? Let's say, for assumption, it was in Python, right? Think about what sort of constructs are needed to produce something. A what? A loop. Yeah. Might very well be a loop. Well, it's doing something similar on multiple times, right? At least it's printing this give me a number 5 times. So this is the code that I wrote for the previous program. And those of you who said 11, that would have been correct for this example code. But something to keep in mind here is that the program could have done anything after this point, right? Just because there was a pattern doesn't mean that this pattern has to be followed. But part of reverse engineering is that we have to make some assumptions in order to make our lives easier, and in order to, actually do stuff. Because if you don't make any assumptions, sometimes it's very hard to get anywhere. That leads me to Occam's razor, which is that the simplest solution is often the right one. So oftentimes, if you have to make an assumption, the simplest assumption is the right one. Now, that's not always the case. You always have to keep reevaluating your assumptions and think about, okay, what happens if what I assumed is actually incorrect? Like for the previous code, what happens if our code was like this? Where after 20 iterations, it flips value. I mean, it could be. We don't know. Do we care? I don't know. Depends on the program. Okay, now let's talk about some techniques. All right. So first technique, or series of techniques I'll talk about is for static analysis. There's a couple of techniques such as function rewriting, where you simplify complex parts of code into simpler portions. And there's also known patterns that you can look for, right? Once you do reverse engineering more and more, you'll start to pick out little things that just keep coming up again and again. One of those things is a loop. There's so many different ways to do a loop, and it's one of the most common parts of computer science. And we'll see some examples of that later. Decompilers, we'll talk about that more, reverse engineering too. But that's just a way of turning really low-level assembly into higher-level C or other languages. And we'll go over that more next at reverse engineering too. So let's look at this example. Here's a little snippet of Python. Can you simplify this code? I'll give you guys a moment to think about what this code does. Declares an array of 10 elements. And then there's something here. Can we simplify this? What does this look like? Can anyone have any ideas? Yeah. Array assignment. It is an array assignment. But what is this? Like, what is this while loop doing here? Yeah, I'm iterating through array. Well, I'm setting up an array, right? Iteratively. So we can simplify this as a for loop. As a for loop, where you just count down from 9 to 0. You subtract 1. Can we make this even simpler? Does it matter if we iterate backwards or forward? Does it matter? Not in Python. We make it even simpler. Right? This is the weird Python notation for array constructions. So these are all equivalent versions of the same code. And they're simplifications of each other. Right? We can see that this one is the most complicated. That's the first example we had. This one arguably is the simplest. Maybe I might say this one's simplest. So which is the most useful to us? Depending on the program, maybe there was a reason the programmer wrote the loop to be like this a while loop at the upper left here. Maybe there's some underlying data structure that would have been better represented or better understood if we iterated in reverse order, or maybe not. So these are questions to consider as you're doing reverse engineering: is what sort of information do we want to preserve as we understand the program? Because as you're sort of going higher up in the abstractions, you're getting more and more abstract, right? This bottom left example here is very easier, simpler to understand. You're also losing information about the original program. And sometimes that's okay, sometimes that's not. This comes down to like making assumptions again. Maybe we can make assumptions that it doesn't matter what order we iterate the array in. Maybe we can. All right, now let's talk about dynamic analysis. So dynamic analysis, as I've said earlier, is about running code. The two techniques I've highlighted here are partial evaluation and modifying programs. So in partial evaluation, you're taking a shorter section of code and just running that section. Sometimes it's helpful if you see you've got a small snippet of code that doesn't really depend on anything, or that you know the inputs to. You can just run it. You don't have to figure out what it does. Just run and see what happens. Now, modifying programs is helpful if there's some sort of behavior you want to avoid or some behavior that you want to add. And that could be a lot easier than just understanding the program through static analysis. These are some advanced techniques that we'll go through in Rev 2. If this is something you're interested in, you should definitely come out to that. We do have a side channel CTF challenge. It's called Slowpoke today. And if you're interested in learning more about that, I can also talk about that later today. But these are mostly be covered in Rev 2. All right, now let's go through an example. Before we start the example, any questions we've got so far about any of the slides? Anyone on Zoom? No? Okay. All right, let's go through this example. So here I've got a big piece of Python snippet. It takes in some input at the very top. It asks for the flag, right? And then it does some sort of processing. And then at the end, it prints either wrong flag, or if it's correct, it will just not print wrong flag. I forgot to add something down here that should be like correct flag. But we want to avoid this. We want to avoid this wrong flag print. So how might we go about doing that? Any ideas? Any suggestions? How do we get started? What do we look at first? I'll give you guys a moment to think. Yeah, if this syntax looks intimidating, it's this is a integer division. That double slash there. But. Okay, so one of the things that we can get started on is look at this while loop here. Maybe this is just a for loop, right? We can simplify this a lot. So let's simplify this. Let's simplify this into a for loop. A little bit better. Still hard to understand. I mean, I don't know what that is. That big, those two lines right there with the VA and ARR. That looks pretty complicated. What if we don't need to figure out what it does? Right? What if we just run the code, do some dynamic analysis? So there's two ways to go about doing that. We can partial evaluation, or we can patch in a print. First example here, we can just add in a print statement, print the array. And it'll just print. That actually turns out to just be the flag, because as you can see on this line, it just compares that array to the input flag. So that is just our flag right there. It's literally FLAG. And then another way is to evaluate a little snippet of the two lines in Python, in a Python. So in here, in this case, we just run those two in a Python REPL, and we get the result. So I know this is a very simple example. Nothing we'll do today will be this simple, but hopefully this gives you a taste of what reverse engineering is like and some of the techniques used. All right, go try some challenges. ctf.sigpwny.com. I'd recommend starting off with Python RE1 and go through the Python RE, the series in that order, in the order of the numbered. If you don't have Python installed, be sure to check out our slides from the Rev0 setup meeting that happened this Sunday. You can also raise a hand and one of the helpers will help you out. All the challenges today will be in Python, so you won't need anything else. Later on, we'll talk about more advanced techniques, just decompilation and GDB. So yeah, let's get hacking. Next meeting, real quick before you guys start working on these. Next meeting, we've got OSINT next Thursday. So if you want to learn how to professionally stalk people or gather information online using open source means, be sure to come out next Thursday. I will say that OSINT is one of the most beginner-friendly areas. So if the stuff today or last week seemed really over the top for you, OSINT is really beginner-friendly and a lot of fun. And of course, fall CTF this Saturday. I think I've said that enough times. Yeah, that's the meeting. Thank you for listening.